Hello and welcome back to Project Infinity. Today let us discuss what are those important topics to do before JEE Main. If you are struggling with mathematics, kindly follow what I have said inside this video. Alright, we are back with our slides. So let us see. These are the chapters to be studied, the topic's name, and how much marks you can expect. This is based on assumption. So let us see. So from chapter vectors, you only need to do vector product and also dot product, the product formulas. So you can expect 12 marks, 3 questions. So next, 3D geometry. There the skew distance, which is the distance between two lines, the shortest distance. Then foot of perpendicular, and if you know foot of perpendicular, you can also do image. So these questions. Then in limits, continuity, differentiability, I have only stated the limits. So properties of limits, mainly they ask 0 by 0, 1 by infinity, infinity by infinity. You can see the marks, how much one question usually comes. In sequence and series, VN method, very important. Basic AP/GP formulas you should know. Then in matrices and determinants, here you have to study adjoint properties. Many times question come from this. Then system of equations, obviously we will use Cramer's method. And theory of equations, here you know basic formulas of the roots, then Newton formula. Don't worry, I will discuss all this inside this video only. Then statistics, all the formulas, because statistics is purely formula based questions. Then probability, Bayes theorem, total probability theorem. Then in integration, King's rule and other properties of definite integration. Then Newton-Leibniz theorem, so integration is also important. Then in binomial theorem, remainder questions, a number of rational, irrational, all these things. So you can see how many chapters I have told. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So 10 chapters I have told. And expect 56 can be plus minus 10. Yes, basic things you should do. So let us discuss what I studied before JEE Main. All with the first chapter, vectors. So here you need to know the basic formulas. A dot B, which is mod A mod B cos theta. Then you have A dot A, this is mod A square. If A dot B equals to 0, this implies A perpendicular to B, or A equals to 0 or B equals to 0. By the way, these are all vector quantities. Then I dot I equals to J dot J equals to K cap dot K cap. This is equals to 1. If other things, I dot J equals to J dot K equals to K dot I, this is equals to 0. Why? Because you know that these are mutually perpendicular. Okay. And for cross product, similarly, you know A cross B mod A mod B sin theta n cap. What is n cap? N cap is unit vector perpendicular to both A and B. If A cross B, this is equals to 0, this implies A parallel to B, or A equals to 0 or B equals to 0. Now suppose A is our x1 I cap plus y1 j cap plus z1 k cap, and B is our x2 I cap plus y2 j cap plus z2 k cap. So what will be A dot B? A dot B simply x1 x2 plus y1 y2 plus z1 z2. And if we need to know A cross B, this is I cap, j cap, k cap, and inside the matrix you need to put x1 y1 z1, x2 y2 z2. Next thing, suppose this is a parallelogram made with A vector and B vector. So the area of this parallelogram, this is equals to A cross B. an area of one triangle, this is half mod A cross B. Also, area of parallelogram can be written as half product of diagonals. And now the most important formula from this chapter, you should always remember: A cross B square plus A dot B whole square, these are vectors, this is equals to mod A square mod B square. Generally we give this a name. What is the name? Lagrange's identity. This was the first chapter. Move on. This is second chapter, 3D geometry. Here you need to know the shortest distance formula. Suppose L1 is A1 plus lambda B1, L2 is A2 plus lambda B2. So what will be the shortest distance? Shortest distance formula is B1 cross B2 dot A2 minus A1 divided by B1 cross B2. And suppose if L1 was A1 plus lambda B and L2 was A2 plus lambda B, so shortest distance here it will be B cross A2 minus A1 by B. So these are the most important things you should know. Next chapter is our limits. Here you need to know the formats: 0 by 0 format, infinity by infinity format, and 1 to the power infinity format. There are 7 indeterminate forms. These are the most important ones. Let us discuss one by one. If 0 by 0 format comes, directly apply L'Hopital's rule. Now if 1 to the power infinity comes, the system is, suppose with an example I am writing, limit x tends to a fx gx. Suppose this format turns out to be 1 to the power infinity. What you will do? You will simply do e to the power limit x tends to a fx minus 1 into gx. Next is infinity by infinity format. Suppose it is in the format numerator by denominator. Here if you get numerator is greater than denominator, answer is infinity. If numerator is lesser than denominator, answer is 0. And if numerator is equals to denominator, you will use highest coefficient of numerator by highest coefficient of denominator. So these are the all from limits chapter. Next we move on to sequence and series. So here you need to know the basic APGP formulas. Let us write down one by one. So arithmetic progression, AP, you know an, this is equals to a plus n minus 1 into d, and summation of n terms, this is n by 2, 2a plus n minus 1 into d. Also this is n by 2, a plus l, where l is the last term. And from GP you know an, this is a r n minus 1, Sn is a rn minus 1 by r minus 1, and summation of infinite terms, this is s infinity a 1 minus r. So next up we have matrices and determinants. Here main questions come from this pattern based, where you are given a, you have to find a square, then a cube, then you will generate a pattern and you will find a, then solve the questions. Next type of questions come from adjoint properties, very important. So I am writing those properties. Adjoint A, this is modulus A in. Adjoint k a n. This is k n minus 1, where n is order of matrix A adjoint a n. Next, adjoint A modulus mod A n minus 1. Adjoint A, this is mod A n minus 2, and modulus of adjoint A, this is equals to mod A n minus 1 whole square. So these are some of the properties. Next up, Kramer's rule. So what happens is you are given three equations. So I am writing them. Suppose you are given, here you need to write the coefficients of x, y and z and name it d. This is alpha, beta, gamma, alpha, gamma, alpha, beta, and you find d. Now from here you will get two cases. What are the cases? Suppose that is not equals to 0, and the second case is d equals to 0. So if d is not equals to 0, then also you will get two cases, d1, d2, d3 not equals to 0. d1, d2, d3, what are they? They are writing the constant in place of those coefficients, which means d1 is writing the constants in place of alpha, beta, gamma. In d2 you will write the constants in place of beta, gamma, alpha, and so on. You will replace the constants in. So here you will get consistent solution, non-trivial, and unique. Second case, d1 equals to d2 equals to d3 equals to 0. So here also you will get consistent solution and trivial. The second case where d equals to 0, you will get first case where d1 equals to d2 equals to d3 equals to 0. This is infinite solutions and consistent. If any one of d1, d2, d3 is not equals to 0, here you will get inconsistent solution. Next topic, theory of equations. Here you need to know, suppose this is a quadratic equation, roots alpha, beta. So sum of roots, this is equals to minus b by a, sum of roots alpha plus beta, and then product of roots, this is c by a, alpha, beta. Basic things. Also, if you are given a cubic equation, then also similarly interchange will happen, minus plus then again minus. Suppose ax cube plus bx plus c, bx square plus cx plus d equals to 0. Here roots are alpha, beta, gamma. You will get alpha plus beta plus gamma minus b by a, alpha beta plus beta gamma plus gamma delta, gamma alpha. This is equals to c by a, and alpha beta gamma, this is equals to minus d by a. And the next thing, which is most important thing, this is Newton's formula, Newton's theorem. Suppose here the quadratic equation is ax square plus bx plus c equals to 0, and you are also given in the question Sn, this is some alpha n plus minus beta n, where the roots of this equation alpha and beta. So what you can do is, using this formula you can say a Sn plus b Sn minus 1 plus c Sn minus 2, this is equals to 0, and from this equation you will find the required solution. So chapter number 7 is statistics. So in this chapter you need to know the basic formulas, starting with mean. X bar, this is equals to summation from I to n by n, and if function is given, then fi, xi, fi. Variance, this is equals to, and I write it with sigma square xi square by n minus mean of square. It can also be written as xi minus x bar whole square by n, same thing. And also you need to know standard deviation. This is sigma, so this is plus under root variance. Next is the important chapter, probability. Here you need to know total probability theorem. So total probability theorem PA, this is equals to P event 1 PA such that event 1 has occurred plus P event 2 into PA such that event 2 has occurred, like this up to P event n PA such that event n has occurred. So this is equals to, I can write as summation of from I 1 to n P event EI probability A such that event EI has already occurred. So this is the basic formula for total probability theorem. Suppose this is the total and these are small events, event E1, E2, E3, E4 and so on up to En, and this is our event. So this is A. This is the diagram for total probability theorem. Next thing is important is Bayes theorem. Bayes theorem, or you can also tell it as blame game. So here the figure is like this. Suppose this is B1, B2, B3, B4, so on up to Bn, and this is our A. So Bayes theorem says that probability of Bi such that A has occurred, this probability Bi into probability A such that Bi has occurred divided by Pa. This is Bayes theorem. And here also Pa is what? Pa is total probability theorem. Summation I equals to 1 to n P of Bi into Pa such that Bi has occurred. So these are the basic formulas, and mostly questions come from either Bayes theorem or using total probability theorem. Next chapter is integration. Now this is a very vast chapter divided into definite and indefinite. Mainly definite integration questions come, and those two from the main formulas or the properties of definite integration. So let me write down some of the properties of definite integration. So you can change the variable. Fx dx can be interchanged to ft dt. Integration a to b fx dx. Now if you interchange the limits, minus from b to a fx dx, a to b fx dx, this is equals to a to c fx dx plus c to b fx dx. This can be broken into various small integrals. You can do questions from this. Then is fx dx a to b. Now this is important. A to b f of a plus b minus x dx. Another formula, fx dx 0 to a, this is equals to 0 to a f of a minus x dx. Then we have from 0 to 2a fx dx, this is also important. This is equals to 0 to a fx dx plus 0 to a f of 2a minus x dx. And last formula is fx dx, not formula, these are properties, minus a to plus a, this is equals to, here are two conditions, it is 0 if fx is odd, and 2 times from 0 to a fx dx if fx is even. Next we need to know the Newton-Leibniz rule. So let me write it down. Leibniz rule. What is this rule about? Suppose we need to do a differentiation of an integral ft dt, and the limits are also functions gx and hx. This rule says that this will be equals to f of the upper limit hx and differentiation of the upper limit h dash x minus f of the lower limit gx and the differentiation of the lower limit g dash x. Now this is also a very important formula. Many a times questions have come from this formula. So this is our final chapter, binomial theorem. Here mostly questions come from the expansion, so you need to know how to write the expansion. And then we have remainders. The question will be asked that what is the remainder if such is divided by this. There also you need to write the expansion. And the most important topic is find the number of irrational or rational terms. Here let me show you a trick. Suppose I have a 1 by n1 plus b 1 by n2 to the power k. Suppose this is our binomial expansion, and I need to know how many irrational terms are there or rational terms are there inside this binomial expansion. So things to be noted is a comma b both have to be prime numbers. Now what you have to do is you have to take LCM of n1 and n2 and let the LCM is m. Now you have to know how to write box product, k by m box product, and let it is c. So this is step 1, you need to check it is prime numbers. Step 2 LCM. Step 3 the box product. Suppose this is c. Now you just write the expansion. What is expansion of this? tr plus 1. This is equals to a 1 by n1 k minus r 1 by n2 r. Now in this expansion you put r equals to 0. After putting r equals to 0, you need to check that if a k by n1 b r by n2, this whole term is rational or irrational. If this is rational term, then you need to do c plus 1 over here, and the final answer is this. And if this is not a rational term, then you no need to do c plus 1 over here, only c is your answer. So let me take an example, a previous year question. So here the question says 3 1 by 2 plus 5 1 by 4 to the power 680. Here I need to say how many rational terms are there. So first of all, my step 1 is to check 3 and 5. Yes, both are prime numbers. Now step 2, LCM of 2 and 4. So this is 4. Step 3 is 680 by 4 box product. This turns out to be 170. Now next step is to write the expansion. So tr plus 1, this is equals to 680 cr, here also kcr, and 680 cr 3 680 minus r. And if you are told what is how many irrational terms are there, you simply know that the number of terms inside this is 681. So 681 minus 171. So like this you can find the number of irrational terms or rational terms. I hope this is clear to you. Please make sure you like the video, drop down your thoughts inside the comment section, and I will be back with more such amazing content. Thank you.